Happy Tuesday, everyone. Among other things, March has been deemed Optimism Month, so with that at the forefront of our thoughts, we embark upon today's edition of Green Builder Media's Impact Series, Game Changers in Sustainability. Today, we'll dig into the science of climate with Dr. Heidi Cullen of Climate Central. Before we get started, I wanted to tell you that today's webinar would not be possible without the support of our generous sponsors. And those sponsors are BASF. BASF is a leader in the construction industry. With more than 600 products serving 75 construction product categories, BASF offers the broadest portfolio of products used directly on construction sites or integrated into other products to improve the performance of construction projects. BASF is also a global leader in sustainability and corporate social responsibility, committed to constant improvements in safety, protection of health, and environmental conservation. Bio-based insulation. Bio-based insulation spray polyurethane products help to lessen the environmental impact of residential and commercial structures by sealing and insulating in one step. Bio-based insulation integrates rapidly renewable ingredients as replacement for a portion of the petroleum in many of their insulation products without hindering performance. And they have replaced chemical blowing agents with water. DuPont. DuPont puts science to work by creating sustainable solutions essential to a better, safer, healthier life for people everywhere. DuPont is focused on dynamic science that generates real-world solutions. That's why DuPont is at the forefront of building science with brands you depend on like Tyvek, Sentry Glass, Corian solid surfaces, Zodiac quartz surfaces, and Kevlar. Green Builder Coalition. The Green Builder Coalition amplifies the voice of green builders and professionals to drive advocacy and education for more sustainable building practices. For more information, log on to greenbuildercoalition.org. And Uponor. Uponor is a worldwide supplier of radiant heating and cooling, plumbing, and fire sprinkler systems that provide energy and water efficiency to homes and businesses around the globe. To learn more, please visit www.uponor-usa.com. I'm Mike Collignan, Executive Director of the Green Builder Coalition, and I'm sitting in for Ron Jones today, so I'll be your host and moderator for today's webinar. Now, I hope that during the course of today's presentation, you'll submit questions for our guest. To do so, simply use the small box at the bottom of the Q&A. I'll review those questions and pose them to Heidi during the Q&A time set aside near the end of the webcast. Now to introduce today's speaker. Dr. Heidi Collins serves as the Chief Climatologist for Climate Central, a nonprofit science journalism organization headquartered in Princeton, New Jersey. She's also a visiting lecturer at Princeton University and a senior research fellow at the Wharton Risk Management and Decision Processes Center at the University of Pennsylvania. Dr. Cullen also authored the book, The Weather of the Future. Before joining Climate Central, Dr. Cullen served as the Weather Channel's first on-air climate expert and helped create Forecast Earth, a weekly television series focused on issues related to climate change and the environment. Prior to that, Heidi worked as a research scientist at the National Center for Atmospheric Research in Boulder, Colorado. She's a member of the American Geophysical Union, the American Meteorological Society, and the Society of Environmental Journalists. Dr. Cullen also serves as a member of the NOAA Science Advisory Board. She received her Bachelor of Science degree in Industrial Engineering from Columbia University and went on to receive a PhD in Climatology and Ocean Atmosphere Dynamics at the Lamont Doherty Earth Observatory of Columbia University. Heidi, welcome to the Impact Series.
Oh, thanks so much, Mike. It's really great to be here, and thanks to everyone who works in the green building space. I just am so grateful for folks who are committed to energy efficiency and renewables. I think it's so important. So I am looking forward to talking to you guys today, and I welcome the questions at the end. And just figured I'd kind of walk you through some of the latest polling research and give you an update on the latest in U.S.-based climate science research. As some of you may already know, the feds basically are coming out with the National Climate Assessment later this year, and the draft document is out, and it's a wonderful overview of the state of climate science impacts in the U.S. So I figured I would walk you through some of the findings there. And, I think on a certain level, it all falls under this overview of how do we make climate science local? How do we make it relevant to people's lives? And how do we take this information and these long-term forecasts and actually make them useful? Interestingly enough, when you poll many Americans, their sense of climate change is still that it's a distant problem in space and time. It's a problem that affects other people in faraway places on timescales that aren't really relevant. And I think that what the science has come to show us is that that actually isn't the case, that we can actually see climate change happening right here and right now. And the question is, how can we make smart decisions based on that information? So I mentioned I would talk a little bit about some survey work. Wanted to show you the update of the Six Americas survey, which is done by Yale and George Mason University. And really what it does is it helps us take a look at where Americans fall with respect to their belief, if you will, in the science of climate change and what they feel about global warming in general. And I'm sure for folks who are out in in um, in the community and dealing with different people, I'm sure you probably run across these different segments, if you will. Basically, what the survey found is that when it comes to climate change, there's really six Americas, and they range from the alarmed all the way through to the dismissive. And this poll has been going on for, I guess, about 4 years now, and the most recent slice was done in September of 2012. And basically what it's shown is that there's kind of been a shift back towards the more concerned and alarmed of the categories. And the way social scientists look at this is that the two extremes, the alarmed and the dismissive, they make up the issue public, and the issue public are generally the folks who pick up the phone and call their elected officials to express their strong feelings about an issue. And we can see now that the alarmed is about 16%, and that's shifted dramatically. I'd say that back in 2009, 2010, we saw a real push down towards the right side, if you will. And folks will say that that was due in large part to just the recession, and that people really didn't have time or room to think too much about climate change. The other part of the survey actually looks at, okay, what kinds of questions do people have about this issue? And as you might expect, the folks who fall into the alarmed and the concerned category, they really want to know what they can do to stop it, how they can help, what they can do about climate change. And I would think that these are the folks who are very proactively looking for ways to make their homes more energy efficient, to invest in renewables and things of that sort. These are the folks who are really engaged to make a long-term investment in fixing the problem. The folks in the middle are still kind of trying to figure out how it affects them personally. I said at the beginning, it feels like a distant problem to a lot of people, for these folks especially, and they want to know, what does climate change mean to me where I live in my backyard? And then for the folks kind of on the right side of the spectrum, they are still struggling with the science and the data, and they really aren't convinced that this is a real problem. So, it really does depend on who you're talking with in terms of the kinds of questions that they would have about climate change. So, I guess as someone who spends time in the community just talking about the issue, I've come to see that there's a couple of key points that I think it's really important to walk through with people. And I think that it kind of boils down to five basic categories. One is the question of is it real? To really help explain to people that climate change is real. The second would be that it's actually caused by us, that it's our fault, if you will, or that we are playing a role in the warming. Third would be that this is actually a threat. The folks in the middle, I was saying before, they really want to know, how is it going to impact me? And I think it's important to explain to people why scientists see this as a very serious threat. Um, Fourth would be that we can actually fix this. For a lot of Americans, don't tell me about a problem unless I can fix it. I want to know that I can solve these problems, and I think it's really important for scientists to talk about solutions. And then finally, there is this issue of consensus. I think it's really important for folks to understand that, for the vast majority of climate scientists feel strongly that this is a serious issue and that we know enough to get started on it. In fact, there was a National Academy of Sciences report that came out back in 2011 called America's Climate Choices. And, the big takeaway was literally that, we don't know everything. We don't have all of the answers with respect to climate change, but we have a lot of answers and we know enough to get started on solving the problem. And it is indeed solvable. So, with respect to the it's real part, I think really just walking through and explaining to folks that, in general, climate change, or what we call global warming, is this large-scale surface temperature increase, about 1.3, 1.4 degrees Fahrenheit over the past century. And that also at the same time, it doesn't mean that it's warming uniformly everywhere. And interestingly enough, when you really look at the way climate change has played out, you'll see that, since 1980, really, we've seen the majority of the warming take place. And in fact, all 12 years of the 21st century rank among the 14 warmest on record. And I think it also really helps for people to understand the big picture perspective because, as climate scientists, I think one of the mistakes we've made is we've gone straight to, the it's us part without acknowledging the significance of natural climate variability, how important Mother Nature herself is in this issue, so that, we do still expect there to be tremendous variability within the system, but that variability is going to play out, on the background of this overall warming trend. And that when you look back in the past, over the vast history of our climate, there were indeed periods that were warmer. We weren't around during those periods. You look at the KT boundary, the Cretaceous, even coming out of the last ice age. I think it's helpful to explain to folks that, when we came out of the last ice age, we were 9 degrees cooler than today. But that warming, that it really is about the rate of change. The warming that took place during the end of the last ice age, it took place over thousands of years, whereas we're seeing this warming play out over a really scrunched down time frame, if you will. It's a lot of warming over a really short time period. And, with respect to the, we know that it's real, we know that it's us part, like I said, I think it's really important to bring in the large-scale natural climate variability that's in play, but to also just make the connection to how we know that CO2 increase that I showed you in the previous slide is actually connected to the warming itself. And there's a lot of different lines of evidence that you can point to, but one that I really like to show folks is the work that was done by Dave Keeling at Scripps, and just this incredible lifelong obsession, if you will, that he had with very precisely measuring carbon dioxide. And he's the guy who basically said, you know what? I'm going to measure the CO2 in the atmosphere. All of these scientists are saying that they think that the CO2 should be increasing because of the increase in use of fossil fuels. I'm going to measure. I'm going to actually put them at their word and see if we can measure this increase. And so, he basically took his gas chromatograph and his mass spec up to the top of Mauna Loa, and he began sampling the atmosphere. Basically, it's an atmospheric breathalyzer, if you will, to sample the amount of CO2 in the atmosphere. And this plot here, this now famous Keeling curve, basically shows you the sawtooth increase over time. And this, very expected, if you were Dave Keeling, this expected increase, the sawtooth pattern is actually the breathing of the seasons, if you will, when the leaves drop off and then when spring arrives and the planet takes like that big gulp of carbon dioxide back down, but this steady increase over time. And I think another mistake that climate scientists make is that we don't talk about what Dave Keeling did with respect to chemical fingerprinting and the way that he actually used the fact that there's different flavors of carbon dioxide, if you will, different isotopes of carbon dioxide, and that by virtue of the fact that we know that the C14 and the C13 isotopes, because those are radioactive and they decay over time, that in fossil fuels, which are ancient, they will be completely depleted in C14. And so that he was actually able to chemically fingerprint the fossil fuel-based CO2, and what he basically was able to show us was that today, roughly 1 out of every 4 carbon dioxide molecules in the atmosphere were put there by us. So that was one of these multiple lines of evidence that actually was able to connect the CO2 increase back to our behavior, back to our actions. And like I said, I like to pair this with the acknowledgement that natural variability is significant. I studied for the majority of my PhD thesis really was things like the North Atlantic Oscillation, El Nino, the predictability of these natural forcings. And so it's really important to keep in mind that these things are still in play. But this diagram is just a nice way to kind of take the pieces apart and look at the various components to look at what role that they're playing. And as you can see, just based on the contribution of each, CO2, the greenhouse gases, the methane, the halocarbons, the ozone, stratospheric water vapor, those are the majority of the warming. You'll see that on the right-hand side, that solar irradiance is also a player, but it's much smaller than the CO2 and the methane forcing, the greenhouse gases, if you will. So, I think it's important to make the point that, solar variability does play a role, but it's not nearly as big of a forcing as the CO2 and the other additional greenhouse gases in the atmosphere. And you'll see at the same time that clouds are there playing a role. We know that volcanic forcing is important, but again, these are on different time scales. And one of the things about CO2 that's really important is that it hangs out in the atmosphere for a really long time. And so climate change is one of these tricky risks in the sense that it's hard to see. CO2 is invisible, and it has these built-in time lags. So by the time you really see it, a colleague of mine at Princeton always says that climate change is the biggest procrastination problem out there. The longer you wait to deal with it, the tougher it gets to fix. Because the more you load up the atmosphere with the CO2, the tougher time you'll have pulling it out. So there's that. And then just to give you the big picture perspective, that CO2 really, this is from the ice core data, it actually goes back even further at this point, but just to show you that, the CO2 has fluctuated through time. We know that it's tied with ice ages as well, but, by the end of the century, we're heading towards a concentration of CO2 in the atmosphere that, we have not seen in a really long time, and we certainly haven't seen in any time during which human beings were walking the earth and building these complex civilizations that really seem to be most comfortable within a fairly small envelope of climate variability. A lot of my work as a PhD student was looking at the Holocene, the last 10,000 years, and we really saw that time period of stable climate coincided with the growth of complex human civilizations. So here's a graphic from the NCA, the National Climate Assessment, which, like I said, is available online. And what it really does is give you that snapshot for U.S. temperature projections towards the end of the century. And when I was at the Weather Channel, I always used to try to make this point that, the difference between a weather forecast and a climate forecast is by definition, a weather forecast is strictly defense. We get the track forecast for Sandy 4 or 5 days out. We know that there's things that we can do to prepare. But with climate change, because of, again, the long time lags in the system, the fact that this is something that we are contributing to, we are essentially part of the forecast. So you'll see here lots of different lines that range from a 4-degree increase by the end of the century as opposed to, say an 11.5-degree increase by the end of the century. And that absolutely depends on choices that we make. And those are predominantly going to be energy and infrastructure choices. So we really, part of what we need to help folks understand is that, in essence, what we're doing is giving ourselves the options of creating different futures. And, I talked a little bit about the procrastination problem and the built-in time lags, and you can really see that here in the sense that, up until about 2025, all of these scenarios look very similarly. And that's because the CO2 is hanging out there for so long. And it really is later towards the middle of the century that we see that these choices that we make create radically different futures. So, I talked about also communicating to folks why we think that this is such an important problem, why this really is an enormous threat. And part of it is just that by the end of the century, it'll be a climate that we are absolutely not adapted to. Many scientists will describe it as essentially a radically different planet, a planet that we have not lived on, if nothing else. And so therefore, all of the built-in systems that we're used to and we rely on, it'll be very different in terms of agriculture, water supply, where it rains, where it doesn't. And that becomes a very difficult thing to manage. On the shorter time scales, I think it really is helpful to people to understand how climate change connects back to our weather and the fact that when you increase the overall average temperature of the planet, that affects the type of extreme events that you'll see. So we absolutely expect to see more extreme heat lasting longer over larger periods of time. Similarly, with respect to precipitation, we expect rain to fall more heavily, so increased heavy precipitation events. Basically, just due to the physics of climate change, you increase the temperature of the atmosphere, that holds more moisture. The increase of water vapor in the atmosphere basically means that when it rains out, it's going to rain harder. And I'll show you some really nice plots from the NCA that show you that we can actually measure that already. This next plot is, again, kind of just walking you out through the end of the century and basically showing you that within the NCA, what scientists are trying to do is give us a snapshot of what the U.S. will look like with respect to things like heat extremes. So this is the projected average increase in the number of days with a maximum temperature greater than 95 between 2041 and 2070, compared to sort of the old normal, if you will, of the 1970s to 2000. And basically what it shows you is that the number of 95-degree days will increase, and in some places it'll increase more than others. You can do similar projections with respect to drought, and this is an area where there's really strong agreement amongst the models, and that is just a uniform drying of the U.S. Southwest. Obviously it's already dry there, but interestingly enough, we also have just a huge population increase in this portion of the U.S. where water resources are going to be really challenged. And so, this kind of scenario, there's large agreement, just increased drying. A lot of discussion with respect to the drought this past year and whether it's kind of a sign of a shift. I think it's pretty safe to say that we'll see this drought come to an end at some point, but there's going to be a greater increase in droughts, and and the years in between, which are wet, are going to decrease as we move out into the future. And then there's a lot of work now being done on agriculture, and folks like Chris Field at Stanford and others have done some really interesting research just showing how things like the increase in extremes of heat, so things like increase in the number of 95-degree days, for example, that has significant impacts on crop yields, in addition to just the overall increase in temperature. So needless to say, there's a lot of work being done on ag yields, and for the most part, warmer, drier is going to negatively impact yield, and there's a nice section in the NCA about that. So then I mentioned the observed data part. So this is just actually looking at what we're seeing right now. And really what this map shows you is that the U.S. has warmed not uniformly, and it really makes sort of a nice case for the fact that the southeastern part of the U.S., there's a term that we use called the southeast warming hole, and for the most part, the southeast has shown the least amount of warming. Some folks attribute that to basically sulfate aerosol pollution, and that was kind of masking the warming. And depending on what time period you look at, this is a longer time frame. This is looking out over the past century, essentially. If you look just since the 1970s, the southeast warming hole actually does disappear. So now, during a shorter snapshot, this warming is becoming somewhat more uniform. But when you look back over the longer periods of time, you can see that the southeast is the one part that hasn't seen as much warming as other places, and in some cases, it's actually seen cooling. One of the things that I think is neat, just because I'm a geek, is looking at record highs versus record lows. So again, interesting use of the observed temperature record. So basically the hypothesis you put forth is that in a world where Mother Nature is basically calling the shots, we would expect things to be pretty random, that the number of record highs would match the number of record lows. And back in the 1950s, we can really see that was the case. Today, in the 2000s, we see that now we actually have 2 record highs for every record low. And interestingly enough, when you carry that forward with a climate model, you basically see that by the middle of the century, we're going to see roughly 20 record highs for each record low, and by the end of the century, it would be something more like 50 record highs for each record low. So, it's basically, we're shifting the continuum and the direction of extremes that we'll begin to see. So more heat extremes, fewer cold extremes. Now with rainfall, I think it's a really interesting analysis as well, which is just, again, looking at the physics, expecting that we should see more heavy rainfall events, and then just looking at the data to see how that pans out. So this is a regional aggregation of the percent increase in the number of days with very heavy precipitation, and we consider that the top 1% of rainfall events. So when you've got like 2-3 inches coming down over an hour, it'll be different depending on where you live, but just a lot of rain coming down in a short period of time. And for example, in the Northeast, we see a 74% increase in very heavy rainfall events, and that connects right back to our infrastructure as well. So sewage overflow issues, just where we store our generators, for example, things of that nature. How can we prepare, if you will, for the fact that when it rains harder, and that increases the likelihood of flooding events. So, okay, so we talked about it's real part, it's us, it's a threat, and just wanted to touch briefly on the we can fix it part. And I suspect that you guys think a lot about aspects of this, and to really just say from within the scientific community, we kind of chunk it out into adaptation and mitigation. The adaptation part really being the stuff that we can do now that helps us right now, the investments in infrastructure that we make, and then the mitigation component is just how do we remove or reduce the CO2 in the atmosphere, and obviously that's going to be a big question within states and the whole country over the next few years. There's been a renewed interest in in regulating CO2 emissions, so we'll see how that plays out. But as a climate scientist, I'm always really interested in this kind of 50,000-foot perspective. And Nate Lewis, a professor at Caltech, gives a really beautiful overview of just the state of the energy challenge. And I would absolutely recommend you check out some of his talks. He really lays this out really nicely, and his whole point is just to say that we as a planet, we humans need tremendous amount of energy. Right now we use about 15 trillion watts of energy. By the middle of the century, that's just going to increase, say roughly 30 trillion watts. And the question is, where are we going to get that energy from? There's enough fossil fuels to last us through, but we know that by making that choice, again, thinking of climate change as really just a scenario of different options, that by choosing to stick with the previous fuel, if you will, it essentially guarantees or locks us into a much warmer planet, which is prone to a lot of other risks, essentially. And this, to me, is just a nice look at kind of the natural the natural resources that the U.S. has, just with respect to things like solar and wind. You can see that the wind belt is stretching from northern Texas all the way up to the Dakotas. The entire western portion of the U.S. has tremendous wind capacity. And the trick really is taking the wind from not very densely populated places and kind of distributing it to the coasts where it's needed. So with respect to wind, there's a lot of discussion about the strength of the power grid. With solar, we know that the U.S. Southwest has tremendous resources, but this decentralized energy, I think, is such an interesting way of looking at it. And when you talk to folks, it's not to say that we should stick 100 by 100 solar panel out in the U.S. Southwest. It's to utilize space wherever we have it, and for example, Germany, not a tremendously blessed country when it comes to solar resources, has made a really significant commitment. They've got less sun than Seattle, but they're the largest solar market in the world, and it really is just, on a state-by-state basis, almost saying, we're going to make the commitment to a given renewable. And one of the calculations that's been done is that even within the state of New Jersey, where I live, where, not necessarily the sunniest place in the world, 50% of New Jersey's electrical load could be served by PV placed literally in this square 10 miles on a side. But like I said, for folks who really work on solar, they're like, don't think of it as, one big slab. Think of it in a decentralized way, because that that kind of frees us up. I mean, thinking of decentralized energy, that makes us all a lot less vulnerable to, the kinds of extreme weather events we've all seen over the past year and more. Wanted to just give you another look from the global perspective in terms of emissions. China, as you can see, is now the top CO2 emitter. And that, in the U.S., we really dipped in terms of emissions. We're back up again, but basically, we did see a dip. President Obama had a target to cut emissions 17% from 2005 levels over the next decade, and last year emissions had fallen almost 11% from the 2005 baseline. And we can look at the main reason for that, but to a large extent, obviously the economy played a big role, but wind and the price of natural gas were actually also really big players in the drop in emissions. So that's kind of brings the market equation in, and it raises some interesting questions. So China's the top emitter, but as you can imagine, U.S. is the top emitter per capita. You can see where China falls on the spectrum. So you can make the argument that just things like energy efficiency in the U.S., tremendous low-hanging fruit. I mean, I really do think that that's the easiest place for us to get started, is to really focus on ways to become more efficient. And when you look at kind of what the broader community is saying with respect to the mitigation realm and where we could focus to make tremendous strides over the next few years, the key areas that are generally recommended are sort of the regulation side, implementing strong standards for CO2 from existing power plants. There's going to be a lot of discussion of that over the next year. Second is interesting. It's one that we don't think about enough, I would say, and there's a lot of good folks working in this space, which is what we call short-lived carbon pollutants, so that the stuff that doesn't hang up in the atmosphere nearly as long as CO2. So it's things like HFCs, hydrofluorocarbons, not necessarily coming out of power plants, but more so found in refrigerators and air conditioners, that if we really target these non-energy sources of emissions, there's a lot of gains to be made there. Third gets us back to the natural gas discussion, and that is really working on tightening up the chain and limiting methane emissions, because methane is an incredibly powerful greenhouse gas, and we really need to make sure that we've got a tight natural gas supply and that we're not leaking methane. And so there's a lot of focus being done on measuring methane leakage rates and just determining what those rates are and should be. And then, like I said before, increasing energy efficiency. There's a lot of gains to be made there, and I think those are really, those are win-wins. And then, just because I'm kind of an infrastructure junkie, to talk a little bit about the adaptation side, and to compare us to other countries. I always say that fundamentally this really is a discussion of our values, how we manage risk in this country, how we think about long-term risks specifically. And you can take some nice comparisons to what other countries have done. So this is a picture of the 1950s flood in the Netherlands, and basically this was a terrible flood. Over 1,000 people died, and the Dutch basically decided as a result of this flood that they were going to invest heavily in their infrastructure. And there's this question of, okay, what do we fortify to? To what level do we build our coastal flood protection? And the Dutch made the decision to build to the 1 in 10,000 year standard. So basically their coastal flood standard is to be ready for that storm that has a likelihood, a frequency of 1 in 10,000 years, a 1 in 10,000 year event. Now, does the U.S. need to fortify to that standard? I don't think so. Basically, 2/3 of the Netherlands sits at or below sea level. We don't have that same kind of problem. But, that's a standard that they built to, and, here in our country, we'll also have to decide what standard are we going to build to. Right now, we say the 1 in 100 year flood, but because the statistics are changing because of the heat extremes and the rainfall extremes and the way they are being modified as we move forward, right now the 1 in 100 year flood actually happens, at more of like a 1 in 80 year type of event. And if you listen to, Governor Cuomo and Mayor Bloomberg and others and Governor Christie, they feel like they've been experiencing the 1 in a 100-year flood a lot more frequently. But the bottom line is we know that those frequencies are changing. And that kind of brings us to the discussion of Sandy. And for someone like me who's been talking about climate change for a long time, it really did feel like Superstorm Sandy. I mean, it really was not your average hurricane. It changed the discussion in a lot of ways. And I think, in the U.S., I think the discussion around climate change, the window was kind of shut for a long time. There was too many large, incredibly challenging problems to manage, and climate change just was pushed to the side for the time being. And Sandy kind of brought that back up. And like I said, I think it does come down to values and this question of how do we invest in our future. And so this is just looking at storm surge over time. The hashed line in the middle between the red and the blue just shows you the component that is driven by sea level rise. Sea level rise is the easiest thing to attribute to climate change. We know that as the planet warms, that ice sheets melt and the seas thermally expand. And we know that basically sea level rise acts as a launching pad for storm surge. And we can see the contributions over time to these various storms here. And, with Sandy, we saw a record storm surge. And this graphic on the right, I just thought was really interesting. And basically what it shows you that in green are the historic wetlands for the New York area. And then in the next slide here, the blue areas were the evacuation zones. So again, it's this question of, as a society, how do we make decisions with respect to where we build and where we don't, given that we know how risky it is in these situations. So, this is just a recent article in the New York Times that, Cuomo is now essentially trying to deal with adaptation strategies. To what extent do we let people rebuild? I mean, these are really challenging, difficult issues, and obviously it's not going to be easy to make some of these decisions. And I think that it really it requires us to think as a community and find ways to be as fair as possible, but to really think about managing these long-term risks. So I will just wrap it up there with one of my favorite quotes from Sherry Rowland, a professor at UC Irvine, which is, what's the use of having developed a science well enough to make predictions if in the end all we're willing to do is stand around and wait for them to come? So with that, Mike, I will turn it back over to you and see if there's any questions.
Well, thank you very much, Heidi. I think that presentation was very insightful. I think it had some statistics that some of our audience may have been familiar with, and others that probably nobody was familiar with. So that was, I found it incredibly informative. And we do have one question now, and I've certainly got a couple of questions, and so I will invite more questions from our audience if they have them. This question is from Danny, and he asks, let me get the full question here. With at least a 100-year lag once we begin to globally reduce warming gases, and the point that this cannot be a U.S. solution alone, can we realistically expect that mitigation will have any effective results over any finite time frame? Adaptation is a path we should address in the U.S., but the actions need to be radical, such as moving everyone off the coast and protecting our food supply, topsoil and water with correct policies versus other types of policies. The elimination of fossil fuel use, coal, is needed now, but is it politically possible?
Yeah, well, that is a good question. And I think that it's tough. I mean, obviously, it is politically possible, but I don't expect it to be easy. And I think that this is where a pragmatic approach of really pushing for greater efficiency, diversifying our energy portfolio, thinking about a decentralized energy grid. I mean, I think these are all very doable things, but we absolutely need the political leadership to get it done. I hope so.
All right, and we have another one from Kathy who asks, I work with an engineer who believes that climate change is not caused by people. What can I suggest that this person read to convince them otherwise?
As an engineer, I get that question a lot as well from my engineering colleagues. And We have a book called Global Weirdness, which basically no chapter is more than 2 to 3 pages, and it kind of walks through all of the latest science. That book, if you give me your address, I'll send a copy to you. I think that book is a nice overview. I'm trying to think who else has summarized it really nicely. I mean, I talk about it in my book, just, the attribution. This gets to the attribution question. And, there's been just a tremendous amount of research looking at the question of how do we know that it's really us? And so the one slide that I showed of the principal components of the radiative forcing, we really have broken down that problem, and there's multiple lines of evidence. So it's not just Keeling's work, it's the fact that, we know that the fingerprint of warming spatially is the warming that we're seeing is which is essentially warming in the troposphere, cooling in the stratosphere. That is a greenhouse gas forcing, as opposed to, how the sun would behave, things like that. So, actually, I'm going to say the NCA, the National Climate Assessment, because at the beginning, the NCA report also walks through the state of the science, and it gives a really nice overview of the attribution question, which, it's a really important one. And I think especially for engineers who are very science-driven, you really need to prove that point to them. But I will say that the research is really definitive. It's been going on for, upwards of 30 years now, where we've really worked on the attribution problem. So, it's one that we've really wrapped up, I think, very conclusively. So check out the NCA.
Okay. We have a question from my friend Mac. Good to hear from you, Mac. Is it worth our time to persuade the dismissives?
My sense is that for the dismissives, the folks in that far end category, they would really need to hear about climate change from trusted messengers, if you will, from folks that they really trust. And I'd say that a lot of the survey work shows that they don't necessarily trust scientists. They don't necessarily trust the data. And that for them, I think it would take folks that they trust. And it would be, whether that would be their parish priest or someone else, that these are folks who I think it'd be really tough for them to trust the science at this point. Whereas the folks in the middle really just haven't been exposed to the science or to the issue at all. And I think for a lot of people, they see that the outreach efforts would be really well served by reaching out to the folks in the middle.
And your answer there makes me think of the comment from Neil deGrasse Tyson, which is the good thing about science is it's true whether or not you believe in it.
That's right. Everyone's entitled to their own opinions, but not their own facts.
Right. We did get a recommendation from Danny, who asked the first question. He says that the EPA also publishes the Climate Indicators Report, and he finds it excellent.
You know what? That is a great report. Thanks for bringing that up. Yeah, I would, for anyone who's interested, just Google that. It's really nicely done.
We have a question from our friend Darren, who is in your state as well, Heidi. He's in New Jersey.
Cool.
He's asking what you think of FEMA not including climate science, and in parentheses he put sea level rise, in their forthcoming base flood elevation maps for New Jersey.
Yeah, that's such a great question, and I think that, this is going to be an ongoing discussion. I mean, as Darren, I'm sure you know all about, just the flood insurance program and everything that's been going on with the NFIP and the fact that, it's obviously incredibly unsustainable and changes are being made. There was a resolution passed back in June where, there's steps being taken to make the National Flood Insurance Program more sustainable. And, I'm sincerely hoping that including long-term sea level rise projections into the floodplain maps, is going to be part of it. It's just, as you know, these things always take time. But, with Sandy, that speeded up a lot of the discussion. And my sincere hope is that, we're going to take a fresh look at the flood insurance program and really work on updating the floodplain maps so that they are accurate, because there's a lot of work that needs to be done on improving them.
If I could add something to that point, I did a bit of a research on the state of Delaware, and Delaware did take NOAA's report into account when trying to draw the line for flood maps, and they did not necessarily agree with the worst case scenario within NOAA's report, but they did cite it as one of their sources when they went above and beyond what FEMA had recommended for flood elevations.
Yeah. Yeah, but I think this is where, I saw a survey that came out after, after that decision was announced and that, Governor Christie was going to move forward to just get things rebuilt by the summer. And that, when they polled people in New Jersey, they actually came back and said, you know what, we would rather have it take a little bit longer, but do it right. And I think this is where, you know, being outspoken and really, having the community come together to speak with one voice to their elected officials, I think is an important part of this as well.
Well, and when you say that, Heidi, it makes me think of our friend Daniel Wallach from Greensburg, Kansas, and that's oftentimes will be his advice too. Is make sure that you do things right. It does take some patience, but
Yeah.
but ultimately you end up with something much better.
Yeah.
I had a question for you, if I could, Heidi. And understand this may open a huge can of worms. I'm not sure, but right now they're talking a lot in Congress about the Keystone pipeline.
Mhm.
And so before you were talking about energy supplies, um, natural gas and renewables and coal and what have you. Where where should we stand, or where do you stand at least on that method of energy supply versus the environmental ramifications?
Mhm. Well, I guess for me, you know, as an engineer, I'm a pragmatist, but I also really do think it's incredibly important to look over the long term. And you know, it seems that especially with the recent report that came out by the State Department that that the Keystone Pipeline, the science review basically I think created a way for it to be passed. But of course, I would love to see us just make the decision to really move forward aggressively on renewables. I just think that it's the long game that is the smart game, and I think the long game really is around renewables. But but that said, like I think that pragmatically that it wouldn't be surprising to see Keystone go through. But I do sincerely hope that it becomes an opportunity to engage around how we really are going to, you know, I would hope see some kind of price on carbon. I mean, I make the case that from a physical sciences perspective, climate change is tricky because carbon dioxide is invisible, but from an economic standpoint, carbon dioxide is also invisible. I mean, it really there's no implications of emitting CO2 at this point. And you really, when I talk to entrepreneurs, they basically say you can't respond to an issue. You can't innovate around an issue when there's no market signal. And I think that again, the long game suggests that it's really smart to to do that.
Right, and I think it's tough too on the topic of Keystone that you on one side you get the enormous job angle, and
Hmm.
you've got a
That's
country that
right.
has high
That's right.
unemployment, but then you've also got um, uh, a situation where I just from what I have read about the process itself, it just doesn't it just seems very energy intensive for what the output really is.
Yeah. Yeah, and I mean the economics of it still are, they still work. Uh, and I think that this is where, again, we really need to look. We need to bring the economists in and really create a situation where, certain decisions, the final price is a true reflection of the long term impact, and that's just really difficult to do right now.
Right. And Darren from New Jersey again will ask, will Keystone be the nail in the coffin for climate change?
That's another really tricky question. You know, obviously, if you read the work of Jim Hansen, I mean, he really passionately feels that we just, we can't move in this direction. And I guess, again, being a pragmatist and feeling like ultimately, if there's a price on carbon, if we make the investment, in renewables? I mean, I guess I'd like to say that no. I mean, I showed you some of the scenarios and basically what we need to do to aggressively reduce concentrations in the future. And so, there's other ways to slice the pie. But, like I said, it's the biggest procrastination problem out there, and this is just like another form of procrastination.
Let me ask you a question on renewables. We see, obviously, the price of solar. I'll speak specifically of solar. We see the price of solar coming down, which is great.
Mm-hmm.
We also see some solar incentives on the state level going away,
Yep.
or at least reducing greatly. What's your take on, I guess, I'll call them solar subsidies? I mean, we see subsidies on the side of gas and oil. Should we continue to see subsidies on the solar side, even though the price of solar is coming down?
I I I think that it is tremendously helpful. I mean, I think that market incentives are really useful. We've seen it both with respect to wind. I mean, and like I said, with respect to just the overall decrease in emissions, wind production was a big, it was not the biggest. The recession played the biggest role in the reduction in emissions in 2012 from 2005 to 2012. But the pricing of natural gas was part of that, as was wind production. So, I do think that incentivizing smart behavior is one of the roles of government. Because I mean, a lot of this does with respect to the discussion of climate change, one of the bigger looming questions is what's the role of government at the federal level and then at the state and local level. And this is where, you know, the public good becomes a big question. And so, again, if you're playing the long game, pushing these incentives works. And you look at a country like Germany, and you can look at other countries as well. I mean, Germany went with solar. Other countries made other pushes. But if you make that decision at the federal level, I mean, you can really see the impact play out over time scales that matter. So, I would really like to see it continue because it's really, I mean, I think that it's a public good, and it's proven to really been helpful in driving the price down, both for solar and wind.
Right, and I wanted to make sure that I made a mention of Maryland's decision to put large-scale wind
Yay!
farms right off their
Yeah.
coast. I believe that's a first as far as
Yep.
offshore wind, a large-scale offshore wind in the U.S. So
Yep.
they appear to be leading the way in that, and it'll be interesting to see the data that comes out of that. We have more questions from our great audience. I'm going to go back to Mac again. He asks if the scientific community will take an activist role to persuade economists to take a political stand to promote the concepts that you have described here.
Well, I think in many respects, it's not even that the scientific community needs to take, let's say, a hardcore activist role. I think the scientific community can speak clearly as to the risks of this issue. And like I said, I mean, I often say that if you wanted to build the perfect threat, this is exactly what it would look like. Just in terms of, and there's been a ton of research on the way the brain is hardwired to process risk. And climate change is the perfect kind of threat because it basically bypasses all of the standard ways that, our amygdala, our fight or flight mechanism looks at risk. And climate change does not look like a risk to our brain. It's only when you look at the data and you project out over the long term that this suddenly looks like a really big existential risk. And so, it's not even to say, because, this notion of being an activist is really tricky because as scientists and engineers, we really feel strongly that we want to stick to the science. I mean, for me, obviously, I spend a lot of time looking at the mitigation and adaptation side of it as well. And I do think that it's important for scientists to really to reach out and talk to the broader community, economists as well. So yes, I mean, I do think we need to speak to them, and I do think that we need to do more. And I mean, for those of you who follow this, it's been really interesting because Tom Steyer, who is, I mean, I'm assuming he's a hedge fund guy. He's some kind of an investor. Um, but he's become sort of the financier activist, and he actually just announced that he's commissioning, the equivalent of the Stern report for the U.S. And I was really excited to see it because, again, it's going to be very data-driven, but it is simply a report that will look at the costs of inaction. And I think this is where we need our economist friends to really come in and do some of the calculations that folks like us aren't equipped to do, because ultimately the reports that have been done by groups like McKinsey, just really show that the costs of inaction are massive, and that it actually really is much cheaper to solve this problem up front. And you know what? It applies to extreme weather as well. I mean, with Katrina, and even with New York and Sandy. I mean, it was very easy. In fact, the Army Corps of Engineers did a report on what would happen to New York if a Cat 3 storm made landfall, and I wrote about it in my book. And the projections, the model scenarios were essentially spot on in terms of the flooding that we would see in the subways, the Holland Tunnel, you name it. So science is really good, as Sherry Rowland says, of making these forecasts and predictions. But the question is, how do we generate the political will to say, you know what, we're not going to let it play out? And that is the tricky part. So yeah, it's tough. But we need to do it. We need to be able to look out to the end of the middle and the end of the century, and help people work through the economics as well, because that, at the end of the day, this does become a pocketbook issue.
Right, right. We've got a couple minutes left with Heidi. She does have to go at the top of the hour. We do have a couple more in the queue here, if you don't mind, Heidi.
Nope.
We've got Georgette asks the question. Well, she kind of more gives a suggestion of that providing incentives for a limited period of time will assist the renewable industries get a real foothold in the U.S. market, but looking at perhaps a 5-year term instead of just 1 or 2 years at a time.
Mm-hmm.
I'm going to go back to Darren, our friend in New Jersey, and he asks, if natural gas is approved in New York and Pennsylvania, won't that kill renewables for a decade or so?
Well, God, let's hope not. These are going to be two places where big decisions are going to need to be made, and I know that Governor Cuomo is in the process of really working through some of this. So, gosh, I guess I hope not. And if nothing else, I mean, I do think that we absolutely need to work on the regulatory side of the natural gas industry. I mean, we need to know what's in the fracking fluid. We need to set baselines. We need more information as well, about how this is done. I mean, because right now, again, the economics are very powerful. I mean, interestingly enough, a study came out recently that looked at the fact that natural gas prices had actually begun to creep up. And, those coal-fired power plants that we saw being turned off, in 2011, 2012, when natural gas was really low, were brought back online. So we can see really clearly the way the economics of gas affect the bigger picture. But I really hope that we can do this as cleanly as possible.
Well, and it's a finite supply,
Yep.
so it's supply and demand. Darren also wants to share a little New Jersey pride, saying that Cape Wind off of Cape Cod is the first offshore. They're developing 30 megawatts that's waiting on a federal permit. I wanted to go
and
to
it looks like the permits are coming through, Darren. I don't know. I kind of follow Cape Wind, and it sounds like they're making good progress. I don't know.
I want to get to Raul's question here, if I could, Heidi. He wants to know if you subscribe to the accuracy of CO2 as a surrogate for the real climate change, or at least he feels the real climate change, which is the dramatically urgent problem of exponentially increasing thermal pollution, which is causing the anthropogenic climate change.
So is this the urban heat island component? Is that what we mean by thermal pollution?
It might be.
Yeah.
We'll see if he's able to kind of
And
respond
this
to us.
is, well, Raul, this is where I would point you to. There's been some
He
really
says
nice
no.
studies. Oh, so thermal pollution coming from point sources, just from power plants, and I'm trying to get a sense.
Right.
I mean, I feel like there's some interesting research, if you're interested in that topic, by folks like Marshall Shepard at the University of Georgia. That's I think my familiarity with the subject.
Okay, and he just said globally, so I'm not sure.
Gotcha.
to that specific. Last one is just more of a comment from Danny. I suppose we should invoke a Montreal Protocol international process to address climate change. We were fairly successful with phasing out CFCs and HCFCs.
Right.
Of course, we replaced HFCs with the global warming gas. So,
Well, and this is where the short-lived carbon pollutants, folks are really pushing. There's a guy by the name of Durwood Zelke. If you Google him, and the Times actually did a really nice story on, the growth of the use of air conditioning, and basically, the short-lived pollutants are a big component of AC use, and you can make lots of projections that show what that means, both from a climate perspective and an energy use perspective. But when Hillary Clinton was Secretary of State, she made a big push on the short-lived climate pollutants component, and a lot of people say that that's the low-hanging fruit. That if we go after that, it's easier than the CO2 component, and there's a lot of gains to be made in the short run.
well, Heidi, thank you very much for your time and engaging our audience today. I think that they found that probably very helpful. I know I certainly did. And it was such a pleasure to spend the hour with you.
Thanks, Mike, and thanks to everyone who joined in. I really appreciate your time.
I wanted to take one more opportunity to thank our sponsors, which are BASF, Bio-Based Insulation, DuPont, Green Builder Coalition, and Uponor. I also wanted to thank the audience, like I said. Finally, a big, big thank you to Heidi for taking the time to talk with us today. There was a lot of effort put into it, and I'm really glad that she said yes and was able to join us. We hope that you all will join us in 2 weeks for another edition of the Impact Series, Game Changers in Sustainability.